Hello everyone, my most important research experience is about the deposition of semiconductor nanoparticle films of titanium dioxide and nickel oxide by screen printing method. Screen printing is a commonly used technique for depositing thick or thin films which can be conductor, semiconductor or insulator. This experience is also my undergraduate thesis in which I am currently working. The aim of this work is to obtain highly homogeneous and crack-free thin films of titanium dioxide and nickel oxide by optimizing two variables. First, the right quantities of the components needed in the formulation of the pasts to be printed, and the parameters of the screen printing process according to each past. The ultimate objective of this work is to employ these films to fabricate perovskite solar cells. A big challenge is to find a proper method to measure the viscosity of the pasts. This property is important because in theory it highly affects the quality of the printed film. But the thing is that I have very little amount of past because I have small quantities of the chemicals needed in its preparation. So I can't use a regular viscometer because it needs a large amount of past for taking a measurement. To solve this, I proposed a method which is to replicate an instrument called capillary breakup extensional rheometer, with which one can measure the extensional viscosity of a fluid requiring just small quantity of the fluid. This method would use a Arduino module and a stepper motor connected to a capillary tube, which would extend the past from a fixed capillary tube, and the manner in which the past behaves when it's extended will determine its extensional viscosity. Another issue is to prepare the sample, being the sample the substrate together with the printed film, for taking a cross-section image to measure the film thickness. I tried cutting the sample with a glass cutter, but the resulting sample edge was too rough for getting a good or clear image when using scanning electron microscopy. So I tried to perform a thermal shock in the sample by heating the sample up and then rapidly cooling it down, but it didn't work. So I then tried uh, to do the thermal shock with a thinner substrate, and in this case it did work. The cracked sample, as a result, was irregular, but there were some places where it appeared to be quite smooth. So I hope it can be useful to get a good image with the scanning electron microscope. The most important things that I'm learning with this experience are to follow a systematic way of doing the experiments when changing parameters in order to clearly observe the effect of those changes, and also to acknowledge the importance of quantifying the results so as to better understand why a given result is different from other, and not just guessing based on intuition. Thank you.